Welcome to AP Podcast 15.5. This is all about indicators. You guys are familiar with indicators. We've used them mostly, we've used phenolphthalein when we're doing our acid-base titrations. But we did a lab where we used permanganate one time with a computer simulation. And there are a number of them out there. And so we might use another different one this year besides phenolphthalein. But phenolphthalein is the one you're most familiar with. So I just want to give you a little brief introduction as to what they are and how to pick the right one depending on the pH. And so let's look at this quickly. First of all, indicators are weak acids, and look at this. When you have the weak acid there, it's clear, but as soon as it disassociates and you get more of the anion part, it turns color. And so this is a good example of phenolphthalein. Sitting in there, it's clean. As we add base, it gets more towards the red portion. And how do you get rid of that H? Of course, you add OH, right? So that reacts there. And even though we've got this reaction, once this indicator is in there enough, we get that color change. And so it's really controlled by the pH. And the end point of this little reaction is when we get that color change. And that's kind of important. So let's look at this. In the indicators, as you guys well know, the color change is gradual. You got to points last year where you could find, you could do half drops and maybe quarter drops. But a number of you remember the first day we went from clear to bright fuchsia. And then eventually you learned how to do it to where you got a light pink color. And so it turns out that when the ratio of acid to its anion is 1 to 10, we get the best, we get the most noticeable color change. Or I should say we get a noticeable color change. And so if we think about the fact that it's weak acid, that means it has a Ka, as many of you are familiar with and probably tired of. If we look at the Henderson-Hasselbalch equation, if I were to just stick in the 1 over 10 like I've got right here, right? Now that would give me 1 over 10, and so then taking the log of that, we get a -1. So in this situation, the indicator would change its pH from its pKa -1. And so that means now on the way up means like this, when the curve's going like this. So if your endpoint's right here, you want an indicator to do its changing right in this area. And so there's going to be some pKa values for some indicators, and we want to just choose one that's roughly a little less than 1 if we want to pick it for titrated an acid with a base. Now on the other end, if we want to titrate a base with an acid, okay, that concentration would be 10 over 1. You can see right there, if this was 10 and this was, right, if this was 10 and this was 1, we'd get a value of 10. And what is that? That's a value of 1. The log of 10 is 1. And so on the way down, and on the way down we mean we're starting with a base and we're going like this. We want it to be, we want the pKa to be, the pH to be close to the pKa plus 1. And so again, we're looking for that area. And I'll show you a little graph here in just a second. So here's just some general stuff. Whether you're writing things down, write these 2 points down. Okay, usually it doesn't get too technical, but when you choose an indicator with a pKa less than 1, if you're titrating with a base, and greater than 1 when you're titrating with an acid. Okay, probably a little better said than I've just done. So here's an example of a problem from our text, and it turns out that every once in a while we'll see an AP question like this where they want you to pick which base it's going to be, or pardon me, which indicator it's going to be. So here's a couple things. We've got, we're going to look at this figure right here, figure 15.8 in just a second, and we're going to decide which indicators would be best. We want an equivalent of 7. So let's look at this. Now I don't know if you could pause that or not, but you could see where the pH works, all right, based on this. And again, we want that area where it's going to be 1 above and 1 below. So we're looking for 7. We're looking for something that works right in there. So if I go down, it looks like here bromothiamyl blue would be a good one for a pH of 7. Maybe phenol red, but I would probably just stick with that one. And you might want to go with cresol red right here. Okay? It depends. It depends on if you're going up in pH or going down, right? So what's another one? 4.82. Okay, well, let's look at our graph. 4.82. And so I'm looking at somewhere around this area, right? So I look through here, I get bromocresol green, maybe some methyl red. Okay, those are two indicators that would work. And again, a question that we'll see on my test or an AP test is they will give you, they'll say the pKa of, let's say, bromocresol blue, equals a number. I'm just going to pick a number like 1 times 10 to the minus fifth, right? And they'll ask you, and they'll just imagine there'll be a list of a bunch of these, okay? Maybe there's 3 of them. And they're different values here. 1 times 10 to the minus 7, 1 times 10 to the minus ninth. And they'll want you to pick the right indicator for wherever that endpoint is. And remember, when we're doing a strong acid and a base, it was 7. Weak acid and a base, it was above 7. Weak base and a strong acid, it was below 7. So depending on where your equivalence point is, let's say 9 or 5, you're going to pick a different base. And I'll show you a problem right from an AP test that they did just a little while ago. Okay, so that's it for this very brief podcast. It's just an idea of how indicators work. We'll see some interesting demos in class, and we'll see you next time.